the Earth appears to be young at heart. A new study has found that our planet's core is around 2.5 years younger than its surface. Researchers say this is down to a strange quirk in physics known as gravitational time dilation, which was first proposed by Albert Einstein. According to Einstein, your position in a gravitational field changes the rate at which you experience time passing. This means time runs slower wherever gravity is strongest because gravity curves space-time. The phenomenon, called gravitational time dilation, has been demonstrated by putting atomic clocks on jumbo jets and flying them at high altitudes. Just as Einstein predicted, clocks flown at 30,000 feet run faster than those left behind on the ground. Gravitational time dilation can be seen in global positioning satellites which need to have their clocks regularly adjusted. But as the new scientist points out, these time differences are normally fractions of a second, not a couple of years. In the 1960s, physicist Richard Feynman predicted that the difference in age between the Earth's center and surface was about a day or two. That figure has been repeated in a number of scientific studies since, but new research has found it may have been a miscalculation. Ulrik Agerho of Aarhus University in Denmark wanted to study the difference in age between the Earth's core and crust while writing an undergraduate book on physics. He was hoping to include a quote by Feynman about the effects of gravity, on how the center of the Earth should be a day or two younger than the surface. But he predicted the effect of gravitational time dilation would be much greater on Earth than had initially been calculated. He decided to take another look at Feynman's claim. Agerho's team began by working out the difference in gravitational potential between Earth's center and the surface. In classical mechanics, the gravitational potential at a location is a measure of the work done by gravity in moving an object from one location to another. They discovered a time dilation factor of 0.0000000003, which means every second at the Earth's center moves 3 seconds slower. Because the Earth is more than 4.5 billion years old, the difference over its lifetime is a year and a half. The Earth is much denser at its core than at its mantle, and by including the density into the calculations, the researchers discovered the difference in age is 2.5 years.